So continuing on with section 6.5 with graphing other trig functions. Today, on this page, we're going to be graphing the tangent function. And notice it says without calculators again. So we need to think about a few things when we're graphing tangent functions, or at least recognizing that we have a graph of a tangent function. The first thing we have to remember is the quotient property that said tangent is sine of theta over cosine of theta. Now I want you to think back a few chapters ago when we looked at the fact that the bottom is where we find our asymptotes, and the numerator, the denominator is where we find our asymptotes, and the numerator is where we find our x-intercepts. So I want you to remember that anywhere cosine of theta equals 0, we're going to have an asymptote. And everywhere that sine of theta equals 0, we're going to have an x-intercept. And so right here when it's saying below we have the graph of sine and cosine, I didn't graph both of them at the same time because we know what sine and cosine look like. But I want you to recognize, again, that anywhere that cosine of theta would be 0, so think about your unit circle. Anywhere the cosine of theta is 0, we're going to have an asymptote. And anywhere the sine of theta equals 0, we're going to have an x-intercept. So in order to graph this, I went through and looked at the 45-degree angles. And remember that at 45 degrees, sine of theta is root 2 over 2, and cosine of theta is root 2 over 2. And so the tangent is 1. So these become very easy angles to graph. We've got negative 45, positive 45, 135, 225, and 315. These are all reference angles of a 45-degree angle. And so when I'm drawing my graph, here's my y-axis. I'm going to go ahead and put in my x-axis. And I'm going to mark this. We're going to do this one in radians today because I want to make sure that you recognize radians are just another measurement, and we can do it the same way we do degrees. I'm still going to go ahead and make 4 tick marks. And my fourth tick mark ends at 2 pi. My first one is pi over 2. Then I have pi over, just pi, 3 pi over 2, and 2 pi. Where is 45 degrees in that? Because this all says 45 degrees. I want you to think about this in radians. If 45 degrees is negative pi over 4, positive pi over 4, 3 pi over 4, where is that going to fit on this graph? Negative pi over 4, let's do one more tick mark this side, negative pi over 2. Negative pi over 4 is halfway in between 0 and negative pi over 2. Positive pi over 4 is halfway in between here. 3 pi over 4 is halfway in between here. The next one will be 5 pi over 4. That's halfway here. And 7 pi over 4, halfway in between here. With graphing tangent, before I can do anything else, I need to talk about where cosine of theta is 0. Where on the unit circle is the cosine of theta equal to 0? And that happens at pi over 2 and 3 pi over 2. And if we went backwards, at negative pi over 2. And I put a asymptote at each of those locations. The next thing I'm going to think about is where is the sine of theta equal to 0? And the sine of theta is equal to 0, at pi, and at 2 pi. So I put my zeros, I have my asymptotes and my zeros already drawn. That comes from sine and cosine. The rest of this I can plot from tangent. At negative pi over 4, it's negative 1. At positive pi over 4, it's positive 1. At 3 pi over 4, it's negative 1. At 5 pi over 4, it's positive 1. And at 7 pi over 4, it's negative 1. Well, when we have asymptotes, remember last time we did the behavior, the graph approaches the asymptote. But it also crossed over at an x-intercept. It crossed, and so it's going to approach the asymptote here. This approaches down. This approaches up. This approaches down. I have just drawn 2.5 cycles of tangent. Now that means something important. Tangent gets 2 full graphs, 2 full identical graphs in one normal period of sine or cosine. The normal period of sine or cosine is 0 to 2 pi. This gets 2 full graphs in that location. So for tangent of theta, the normal period is 180 degrees or pi. It's not 2 pi and 360 anymore. It's 1 pi. It's 1 pi to get a full cycle or 180 degrees. Cotangent is very similar. The only difference is cotangent of theta is equal to cosine of theta over sine of theta. That means everywhere that sine of theta is 0, we're going to have an asymptote. And everywhere that cosine of theta is 0, we're going to have an x-intercept. The values of everything else on the table is exactly the same because the inverse of -1 is -1, the inverse of 1 is 1, and so on. So the location is the same. So when I graph this, here's my y-intercept, here's my my y-axis, here's my x-axis. I'm going to go 1, 2, 3, 4. Here's my 2 pi. Here's pi. Pi over 2. I'm going to go ahead on this side and put a negative pi over 2 just so we have it. But remember that the asymptotes happened at pi over 2 and 3 pi over 2 because that's where sine is 0. Now those are going to be my zeros. Anywhere that sine is 0, I'm going to have a 0. Anywhere that, cosine was 0 at those locations. So anywhere that cosine is 0, I'm going to have a 0, an x-intercept. Anywhere that sine was 0, I'm going to have an asymptote. And the other values are exactly the same. At negative pi over 4, we go -1. So here's negative pi over 4, halfway in between, down 1. And at positive pi over 4, it's up 1. Wait, we can't cross that asymptote. So it doesn't. We go from the x-axis down, and this is going to go from the x-axis up to the left and down to the right. Look, the graphs are reflections with a shift because cotangent is a reflection of tangent with a shift. So we've got, fill in the rest of our chart, and once again, we have 2 full cycles of cotangent from 0 to 2 pi. So cotangent has a period of 180 degrees or just pi.